Oh, is this? I think I'm recording. I didn't know for sure if I was or not. All right. Let's do some of these problems that we're multiplying complex numbers together. So it follows the distributive property. So everybody in the parentheses gets multiplied by 4i. So I'm going to take 4i and I'm going to multiply it by the negative 2. It distributes over the subtraction, and I'm going to take 4i and I'm going to multiply it times 8i. Alright, so here we just multiply the 4 and the negative 2 together and get a negative 8, but don't forget to multiply it by I. I have a subtraction, so I keep that subtraction. 4 times 8 is 32. And I times I, we can write that as I squared. Now we cannot leave this as our final answer because the exponent on i's cannot be bigger than 1. We have to look at I squared and remember that I squared is equal to negative 1. We had these powers of I should be memorized, and then you can get higher. That should be 1, not I. We can get if you have larger exponents, larger than 4, you can divide by 4, look at the remainder, and it simplifies to either I or negative I. That happens when the exponent is odd, or if the exponent's even, negative 1 or positive 1. So we come over here, and they expect us to replace this I squared with a negative 1. So the negative and a negative turns that to positive 32 to add 32. Now, remember that I think I said this in a previous video, and hopefully I said it in class, that a plus bi is the standard form for a complex number. A is the real part, b is the imaginary part. They normally write the real part first, 32, and then they'll write minus 8i. Not that big of a deal, but you know, if the question actually said write it in standard form, that's exactly how you'd like to write it. Well, actually, to tell you the truth, since it says addition, we would probably write it as 32 plus a negative 8i. But people are pretty relaxed. See, the standard form says to add, and if I'm subtracting, I'll just add the opposite. But most of the time they just write it as 32 minus 8. That's what we're going to write it as. I'm not going to be so picky as to say that you have to change it to an addition problem. So I thought, hey, let's do number 3 next. So I have a product here of 3 numbers. We can look at this as 5 times an I times another I times, we can either say negative 1 times a positive 2 or just keep it negative 2 times I. Well, I can group the 5 times the negative 2 together, and then the I times I times I can think of that as grouped together. So we can multiply in any order, I guess is my point. And a positive 5 times the negative 2 is a negative 10. And I times I times I, well, all of these have an exponent of 1, so you just add those exponents, and we write that as I to the 3rd power. But we need to simplify I to the 3rd power. We know that I to the 1st power is I squared is negative 1, I to the 3rd power is negative I to the 4th power is 1. So this is negative 2 times a negative I. Now a negative times a negative is positive, so we have 10 times I as our final answer. Now of course when you're doing this problem, you don't have to show all of the steps that I did. I mean, you know, I'm just illustrating the justification we're saying 5 times negative 2. Most of you are just going to jump straight down to this guy as being your first step, right? But in case you didn't see that, I'm trying to explain how I would get there. Trying to break it down as step by step as I can. When I have a binomial times a binomial, what I suggest that you do is multiply this in the form of a table. So my first term is 7, my second term is negative 6i for one factor, and then my other factor, I have a first term of negative 8 and a second term of 3i. So let's multiply these values together. Gosh, I have to pause this again. I'll be right back. Okay, I'm back. Probably didn't know I was gone. Positive 7 times a negative 8 is probably negative 56. And positive 7 times a 3i is going to be 21i. Negative times negative is positive, and 6 times 8 is 48. So don't forget the I, 48i. Now this last box is always the one that's tricky. We have a negative 6 times a positive 3, which is negative 18. We have I times I, which is I squared. But we do not want to leave it as negative 18i squared. We want to look at I squared as negative 1. So what we really have to train ourselves to see here is that we have negative 18 times a negative 1. Hey, that's positive 18. So along each diagonal, I have like terms. I can add the negative 56 and 18 together, and I can add the 48i and 21i. And that'll be my final answer, right? If I have, well, I don't want to mess up because it's getting late, and I'm not very good at arithmetic, so I don't mind using a calculator. I get a negative 38 for my real part. Along the yellow diagonal, that should be 69. Don't forget the I. So there's my final answer. And like I say, I use the table to get it. So I thought, hey, why not try number 7? Let's multiply this part together to get a number and then distribute it to the binomial. 7 times 3 is 21. I times I is I squared. That's being multiplied times this binomial. But I know that I squared is negative 1. So I have 21 times a negative 1, and then I'm going to multiply that times this binomial. Positive 21 and negative 1 can't talk, is a negative 21, and that's going to distribute to both of these terms. So a negative times a negative is positive, and this first guy is going to multiply together to give me 168. Negative times negative is positive, and this is going to be what, 126 I. Don't forget the I, and that's our final answer. So like I say, first we did the multiplication outside of the parentheses, found what we were going to distribute through the binomial. So I hope that this is my final answer. All right. Hey, let's take a look at number 11. A binomial times a binomial. I suggest that you use a table. You know, the mathematical property is the distributive property. And some students, however, for whatever reason, have a difficult time sometimes, multiplying and using the distributive property. The table helps keep you organized and is in a very efficient way to apply the distributive property. At least that's my opinion. You'll see people sitting here and drawing, a plan of attack, which is fine, but I don't like all that clutter. I like to keep my tables, and even on this pad, when I do it with pencil and paper, my handwriting is a lot better than on this wireless tablet. This wireless tablet is not the easiest thing to write on. A positive 8 times a negative 4 is a negative 32. Positive 8 times a negative 4 is a negative 32, but now I have I. A negative times a negative is positive, 6 times 4, but don't forget the I. Now I have a negative 6 times a negative 4, which is positive 24. I times I is I squared. I know I squared to be negative 1, so this is positive 24 times a negative 1. That's really the number negative 24. So, along this diagonal, I can combine those like terms. Negative 32 minus 24 is a negative 56, right? You can check me on a calculator because I'm not always sure. Negative 32i plus 24i I think is negative 8i. So let's double check all these arithmetic so I don't make a silly error. Along the yellow diagonal was a negative 32 plus a negative 24. Negative 56, that's what I thought. Along the I here, we've got 24 minus 32. Negative 8, and I have negative 8i. So hey, I did that right. Just wanted to double check. I don't want to make a silly mistake for you guys. And this is my final answer. Hey, let's take a look at number 16. When you have an exponent, think about what that means. That's repeated multiplication. So I have 6i times another 6i times another 6i. Well, I can multiply in any order. So I'm going to first multiply all these 6's together. What is 6 times 6 is 36, but I don't know what 36 times 6 is. So let's grab the calculator. If we have 6 times 6 times 6, 216. Okay. When we have I times I times I, now that's easier for me to figure out. So this product of these 6's, that gave me 216. I times I times I, all of these have an exponent of 1, and when you're multiplying with the same base, you just add the exponents together. So 1 plus 1 plus 1 is 3. Now, when I have a power on my I need to reduce it. If that power is an even number, it's going to reduce to 1 or negative 1. If it's an odd number, like this 3, it's going to reduce to either I or negative I. I know just out of memory that I to the first power is I squared is negative 1, I to the third power is, multiply those two together, negative I, and I to the fourth power is 1. So I have 216, and I know that I to the third power is the same thing as the opposite of I. So let's treat that like a negative 1 and have positive 216 times the negative 1, negative 216 times I. Final answer. Alright, so let's take a look here. Now, remember that we can multiply in any order. If I were doing this, I'd probably hold off on the negative 6i. I'd probably multiply these two binomials together in a table myself. Let's see what we have. We have 8, and the other term is minus 6i. And then across the top of my table, first term is negative 8, and the next term is negative 8i. So let's figure out the entries in our table. A positive 8 times a negative 8 is a negative 64. Positive 8 times a negative 8 is a negative 64, but then we're multiplying it by I. Negative times negative is positive. 8 times 6 is 48. Negative, this is the tricky one, box. Negative 6 times a negative 8 is a positive 48. but I times I is I squared, which we know to be negative 1. 48, positive 48 times a negative 1 is a negative 48. That I squared is always going to change the sign of the number that's in front of it. The number in front of it was 48, and now it's going to be a negative 48. Because that's what negative 1 does when you multiply. It takes the opposite of it. Alright. We've got along that diagonal like terms, and along this diagonal like terms. So let's do our real part first. Let's use the calculator so I don't make a silly mistake. I've got negative 64. Well, if you key it in the calculator wrong, negative 64 minus a 48. Negative 112. Now, along the other diagonal, oh, wait a minute. Yeah. Okay. Along the other diagonal, I have 48i minus 64i. And that's a negative 16i. Alright. Oh, I'm getting tired because remember, that's not my final answer. This, wow, let's use the same color. When we multiply these two binomials together, that's what we get. I forgot, I've still got to multiply that by the negative 6i. So I need to distribute that to both terms. A negative times a negative is positive, and 6 times 112. I get 672. 672i. Now, a negative times a negative is positive, and 6 times 16. 96. Now remember, that was also I times I, which is I squared. But I squared is negative 1. Let's shrink this up. So, I have 672i plus 96 times a negative 1. Now, we normally write the real part first. The 96 times a negative 1 is a negative 96. And then we have the imaginary part second, 672i. So that is my final answer when you take the product of these three values. The negative 6i, one value, times the 8 minus 6i, that's another, times a negative 8 minus 8i. I claim that you'll get this negative 96 plus 672 times I if I haven't made any silly mistakes. So hey, I think that's enough examples. If you need more, ask me questions. I can write some more, either continue doing the problems and the homework there, or just make up some other ones, for practice. Hope this helps, and I will talk to you later. Bye.